Chapter 6 is mainly about factors or factoring. But to understand what factors are, is two things, or it could be more than two, but things multiplied. In this case, I'm looking at 6 and 2. Two things or more than two things multiplied, giving it as a product. So factors of 12 could be 6 and 2. Are not the only factors of 12. We could also have 3 and 4, or 12 and 1. Like there's other factors, but once again, factors are things multiplied, giving us a product. So let's take a look at one thing here. I have this table. Make sure you guys check out my PowerPoints. They're there. This table's there. So this is one that's going to help you guys out. A number is divisible by 2 if it's an even number. That means it ends in 0, 2, 4, 6, or 8. A number is divisible by 3 if the sum of digits is divisible by 3. As an example, a number, let's say the number 5, 4, well, 546. Let's say I have that. 546. I want to know if it's divisible by 3. If I add the digits, 5 plus 4 plus 6, I get 15. 15 is divisible by 3, so 546 is divisible by 3. So that means I could go 3 times something. 3 is a factor of 546. All right, now 4, in order for a number to be divisible by 4, the last two digits from the number must be divisible by 4. So an example, if I had the number 544, I look at the last two digits, 44. 44 is divisible by 4, so 544 is divisible by 4. Now, for this thing to be divisible by 5, the number has to end on 0 or 5. In order for a number to be divisible by 6, it has to be divisible by 2 and 3. So that means it has to be even, because it has to be divisible by 2, and the sum of the digits must be divisible by 3. So it has to follow the rules of 2 and 3. Now, a number to be divisible by 8, the last three digits from a number divisible by 8, and in order for them to be divisible by 9, the sum of the digits must be divisible by 9. So kind of like what we had for 3, we have it for 9. So like earlier I had the number 546, and I said when I add the numbers is 15. That is divisible by 3, right? Because 15 is divisible by 3, but 546 is not divisible by 9 because the digits do not add up to 9 and do not divide by 9. Okay. Now for 10, in order for a number to be divisible by 10, it has to end on a 0. So that's going to help us out a lot. Let's take a look at this example. Find the greatest common factor for each list of numbers. So earlier I said that 12, it had many factors, right? It had 3, 4, 6, 2, 1, 12. So it had many factors. So 30 will have some factors, and 45 will have some factors as well. I'm looking for which one is the biggest, so that's why we call it greatest. Which one is the biggest that it's in both of them? So which is the greatest common factor? One thing that's going to help us out is we call this the tree diagram. So number 30, I'm going to break it into two factors, any two factors. I'm thinking, well, two factors of 30 are 6 and 5. 6, I can break that into 2 and 3. I cannot break them even more, so my factors that I was not able to break down are going to be 2 times 3 times 5. Those are the factors of 30. This is what we call the prime factors because we're not able to break them up even more. Now for 45, let's take a look. Two numbers that multiply equals 45. I'm going to go 9 times 5. 9, I can break it into 3 times 3. So my prime factors of 45 are 3 times 3 times 5. Once again, I'm looking at the numbers. I was not able to break down even more. I noticed that both of them have a 3. You know, the list, they both have a 3. They both have a 5. So I'm going to multiply the common factors, in this case 3 and 5. I'm going to multiply them, and I'm going to say 15 is the greatest common factor that 30 and 45 have. So once again, from the factors that 30 and 45 have, 15 is the biggest. So I did prime factorization of each. I look at the common factors and obviously multiply them. All right, now let's take a look at my example B. Let me erase this for space. 72, I'm thinking of any two numbers that multiply equals 72. I'm going to go 9 times 8. 9, I can break this as 3 times 3. And 8, I can break this as 2 times 4. And then 2 times 2. Let me erase this bottom part right here for space. So I'm going to say the prime factorization of 72 is going to be 2 times 2 times 2 times 3 times 3. Let me bring it up for space. Once again, I'm looking at the numbers. I was not able to break down even more. Now, my second number is 120. The prime factorization of this, let's see. First, any two numbers that multiply equals 120. I'm going to go 12 times 10. Right? My number ends on a 0, so I know I can divide this by 10. So 12 times 10. I'm waiting for this. This thing froze for a minute. So let's see, 12 times 10. Oh. And then remember, 12 and 10, I'm going to be able to break them both. Gotta love technology sometimes. Okay, so I came back. So once again, 120, I'm going to break it as 12 times 10. My 12, I'm going to break it as 3 times 4. And my 4, I'm going to break it as 2 times 2. My 10, I'm going to break it as 2 times 5. So I see 3 2's to begin with. So 2 times 2 times 2. Then I see a 3 and a 5. Times 3 times 5. Okay, so that's a prime factorization of 120. Now 432, my third number, I know I can divide this by 9. I know one factored is 9. And the reason why I know I can divide it by 9 because I added the numbers 4 plus 3 plus 2, which gives me 9. 9 is divisible by 9. So 432 is divisible by 9. So I'm just going to go, let's see, 432 divided by 9 gives me 4 and 8. 48. All right. My 9, I can break this as 3 times 3. My 48, I can break this as 6 times 8. My 6, I'm going to go 2 times 3. And my 8, I'm going to go 2 times 4. And then 2 times 2. So when it comes to number 2, I have, let's see, 1, 2, 3, 4. I have 4 2's. So 1, 2, 3, 4. And then I have, let's see, 1, 2, 3 3's. So 1, 2, 3. So that's a prime factorization of 432. Now, let me see what they have in common. So, to begin with, they all have a 2. Then they have another 2. And they all have a third 2. And they all have a 3. And that's pretty much it. Those are the only common factors that they have, the only common prime factors that they have. So I'm going to multiply my numbers. The groups that I did, I'm going to go 2 times 2 times 2 times 3. Once again, we see what they have in common, so we make a group, and we're going to multiply the groups. So 2 times 2 times 2 times 3. That gives me 24. That's my greatest common factor. All right, for example C, my common factors, my prime factors of 10 are going to be 2 times 5. Common factors of 11, the prime factors of 11 are 11. I cannot break it in more. And then for 14, I have 2 times 7. So it seems like we don't have any common factors. When we don't have any of these, technically, all of these could be multiplied by 1. So whenever we don't see a common factor, we're going to say the greatest common factor will be 1. 1 is a factor of everything. So if we don't see numbers, that we have common prime factors, then we're going to call it 1. All right, so that was not bad. Let's take a look at this one, but now we're going to include letters. I'm not going to do the tree diagram. I'm just going to come and say 21. Once we break it, it breaks down to 3 times 7. 18 is going to break us 2 times 3 times 3, right? We can do the tree diagram to get there. 45, I'm going to say that breaks down as 3 times 3 times 5. And then 24, I'm going to say that is 2 times 2 times 2 times 3. So when it comes to numbers, I see they all have a 3, and that's it. So numbers wise, I'm going to say my greatest common factor is 3. Numbers wise. Now, I see some letters. I see m to the 7th, m to the 6th, m to the 8th, and m to the 5th. Whenever we have letters, we always go with the smallest exponent. So in this case, I'm going to go m to the 5th. So numbers wise, the greatest common factor is 3. Letter wise is m to the 5th. But when it comes to letters, we go with the smallest exponent. Now, we're going to be told on instructions are factor out. So, factor out the greatest common factor. What that means with factor out is basically saying do the distributive property backwards. So, looking at my example 8, numbers wise, I can divide both of them by 5, and letter wise, I can divide both of them by y. Right? The greatest common factor is 5y. So, when it says factor out, I'm going to do parentheses, divide both of them by 5 wide. Let me give myself some room. If I divide each of them by 5 wide, I'm going to get, I know in the first one, the 5's cancel out. I mean, the 5's cancel out. On the y's, I get y because I subtracted the exponents plus 2, right? Because the 10 and the 5 become 2 and the y's cancel out. So factor out the 5 wide, and inside we have y plus 2. Basically, we're doing the distributive property backwards. Now here, numbers wise, I'm going to factor all of them by 5. I can divide 5 from all of them. Letter wise, I'm going to have m to the third. If I divide each of them by 5m to the third, I'm going to get, for the first term, I'm going to get 4m squared. For the second term, I'm going to get plus 2m. And on the last one, I'm going to get minus 3. And there's no m's. I should not have any greatest common factor besides 1. I should not have anything else for greatest common factor on the inside of my parentheses. So when we say factor out, we say, take the greatest common factor out of the parentheses. So we're doing distributive property backwards. Now, let's see. Write in factor form by factoring the greatest common factor. Now, in this case, I see the first term. I'm going to call it all one term because of the parentheses. It's all combined. Okay, so I see this one, and I see the second term. They have a common parentheses. So, matter of fact, what they have in common is a plus 3. So when I do my factors, I'm going to factor out the a plus 3. So basically, I take it out. And inside parentheses, I'm going to have a plus 4. The interesting part, whenever there's parentheses, and it's common parentheses, that's one of our factors. The other factor is basically what we have outside. If you notice, I have a plus 4, and that was my other factor. So for my example B, x plus 1 is my first factor, and then my second factor is going to be x squared minus 5. This is going to be very, very common when we have 4 terms to begin with, and we're going to use a method called grouping. So this is going to be very, very useful then. As a matter of fact, let's take a look at an example of grouping. So factor by grouping, we have 4 terms. So when we have 4 terms, let me take a look at the first 2 terms only. 2x plus 6. And let me factor out the greatest common factor. I can divide both of them by 2. Inside my parentheses, when I divide both of them by 2, I'm going to have x plus 3. Now, let me take a look at my second group. Positive ax plus 3a. I can factor a out of each. And then when I divide both of them by a, I'm going to have x plus 3. I notice that my parentheses are common, right? It's the same thing. So one of my factors is x plus 3. My other factor is going to be 2 plus a. So factoring by grouping is really, really nice because we can do by grouping when we have four terms. So here, numbers wise, I can divide both of them by 6. Letter wise, I can divide both of them by x. So I'm going to factor out 6x. Now, when I divide both of them by 6x, I'm going to have a plus 4. Now, on the second group, positive a plus 4, I have to factor something out. My greatest common factor here it is 1. Remember I said if there's nothing, we don't see anything, 1 will be the greatest common factor. So I'm going to factor it out 1. If I divide both of them by 1, I'm going to have a plus 4. I see my common factor, my common parentheses. So one of my factors is going to be a plus 4, and my other factor is going to be 6x plus 1. So this is going to be nice when we have four terms. We're going to do it by grouping.